In this video, I'm going to talk about how to classify chemical reactions and give you some more balancing reaction practice. So this is all from more or less table 7.3, except for the very last reaction, which is more specific than that. So calcium is an element. Chlorine is a diatomic molecule, but it's an element. Anytime you try to combine two elements to form a compound, it's called combination. It's a nice, easy type of word to remember. You combine two things to make one. The reverse process is called decomposition. So if you take a compound and break it down to its elements, it's automatically decomposition. So like decomposing, breaking into its parts, that's what decomposing bodies do. All right, and so this third type of reaction, got to balance it though. There's 2 irons and 3 sulfurs. When you're balancing any chemical reaction with elements as one of the reactants or products, always do those last because you can change the number out front of this without bothering any of the other elements, like sulfur. All right, so next is an example of a metal element and a metal cation. They're swapping roles by transferring electrons. Now that this is the metal and the other is the cation. And so silver metal, and this ion will be in aqueous solution. So this is how they're usually run, is in aqueous solution. All right, and we still need to balance it. Okay, so 1 copper, 2 nitrates, 1 nitrate, and now I have 2 silvers and 2 silvers. All right, so the reason it's 2 silvers and 1 copper, because this is silver plus, which needs 1 electron per atom. This is going to be copper going to copper 2, which is going to lose 2 electrons. So we have to have the same number of electrons lost by the copper as we have gained by the silver. That's why we have twice as much silver getting converted to an element. This is called a redox or reduction oxidation reaction, where copper is losing electrons. That's called oxidation. And then silver plus is gaining electrons to become silver metal, and that's called reduction. You always have to have 1 oxidation, 1 reduction. All right, another type of reaction that's commonly done is to mix 2 aqueous solutions of ionic compounds, and then there will be some new ion pair that was probably insoluble in water. And so if you take barium chloride, potassium sulfate, and mix them together in aqueous solutions, you get barium sulfate precipitate. A solid comes and settles out to the bottom. It's called precipitation. And so 1 barium, 1 sulfate, 1 barium, that's okay. 2 potassium ions, 2 chloride ions gives 2 potassium chloride ions. So I already balanced that for you. So this is single replacement, double replacement. So when we use the term single replacement, you should have a good idea of who is replacing who. So a metal in a nitrate aqueous solution is being replaced by copper nitrate aqueous solution. And the metal copper is going away, and then silver metal is being made. And so here now we're just swapping. This is called double replacement. And then finally, one example you should be able to do is combustion, which means combining anything with molecular oxygen to create the oxides of whatever elements are here. So I'm going to use the example of ethanol. So carbon combined with oxygen will make carbon dioxide. The hydrogens combined with oxygen will make water. So if you have a hydrocarbon, then you get carbon dioxide and water. So this is pretty much what your body does if it metabolizes ethanol or simple sugar or anything like that. Of course, so every carbon becomes carbon dioxide. So we need 2 carbon dioxides for 2 ethanols. Now we've got 6 hydrogens, so that requires 3 water molecules, 6 hydrogens. Now I have 3 oxygen atoms, and I have 3 oxygen atoms, so it's just one of these and one of these makes a total of 3, so now it's balanced. Okay, sometimes when you balance chemical reactions for combustion, it might be easier to put a fraction out in front of the oxygen, if that'll make it balance, and then multiply everything by 2 to get the simplest integer ratio. So this is called combustion. But if you take the iron reaction, combine iron with oxygen, that's actually combustion. So being the July 4th soon, tomorrow night, you might see a lot of combustion reactions which give off lots of pretty lights. All right, that's it.